Welcome, GED students, to our virtual GED class. We're continuing the topic of data analysis, and I'm going to launch into percentages a bit. Now, not all teachers include percentages under that data analysis kind of umbrella, but I do because they get used a lot in statistics, like 47% of GED students fall asleep in Kate's classes, or whatever. So very frequently used in statistics. And so you're very likely to see them it could come up on your math test, but it also could come up on your science and social studies test with that data analysis. So today we're just going to really focus in on what does the percentage mean. We're not even going to pick up a calculator, which, if you know me, is unusual. And James already has a head start on us for what percent means. It definitely has to do with that, James. He said, does it mean per 100? Oh, James, spoiler alert. I might have to edit that out of the video. You're right. It does. I'm getting there. And we're going to learn to do some mental math there, because a lot of times students only have one tool in their toolbox when it comes to percents, and that's converting into a decimal and doing decimal multiplication and division. But I have to tell you the truth. Decimal multiplication and division is a pain in the butt. Decimals were not really meant to multiply and divide. They don't work very nicely when we do that. And so I am going to use some other tricks to do some mental percentages with you today. Okay, so that's the plan. So let's get started with exactly that. What does percent mean? And James gave us our most common explanation of what a percent means. Percent literally means per or out of. Per means out of. And cent literally means like a century has 100 years, or there's 100 cents in a dollar. It literally means 100. So if I say percent, I'm talking about out of 100. Now, that being said, I have taught you another way to translate the word per besides out of. I, in fact, taught you that per means one of the mathematical operations. Does anybody remember what mathematical operation per signifies?
Division.
Division. Another way to think of percent, it's out of 100. It's literally divided by 100. Divided by 100. Okay, so that's kind of weird to think about. So if you see something like 40%, I'm saying 40 out of every 100. Yes, but another way to think of that is 40 divided by 100. Literally 40 divided by 100, which of course you could write like that. But we often, as mathematicians, use a fraction bar to signify dividing. So 40 out of 100 is another way to talk about 40%. Now, guys, if I typed this into my calculator, 40 divided by 100, anybody have a TI? What do you get if you do 40 divided by 100?
0.4.
You sure do get 0.4. So this is what I want to point out to you, that there's a lot of ways to think about percents. A percent can be conceptualized as a decimal or a fraction. We saw it in both ways, because percent literally means divided by 100. So in this case, 40% is 40 out of or divided by 100. That being said, I really want to talk about what 100% means. So let's start here with 100%. It's really funny how many students I can fool with this question, even though I feel like this is an obvious thing. So if I have 100%, if I have 100 out of 100, how much do I have? Well, if I tell you 100% of my class is currently asleep, what am I saying?
The whole class.
The whole class, everybody, the whole thing. It's one whole thing. In this case, one whole class. 100% is one whole thing. It's all or total. So it makes me a little sad when on, for example, the old TABE test, students would get this problem and to have no idea how to answer it. It tells me that we might have learned a lot of math computations in my class, but you really missed the boat on what percentages mean if you can't tell me what 100% of 4.78 is. Well, what does 100% mean? It means all. It means the whole thing. It means I want all of 4.78. So what's all of 4.78? Just
4.78.
4.78. And we like overthink it. I've seen students do 5 minutes worth of scratch work with all these zeros on the side of their paper. And I'm going, really, y'all? We got to get what this means. Similarly, there's problems that ask something like this. Again, it's not on the GED, it's on the old tape, but we're getting up to the GED level, okay? They would say something like, you know, what is 2.7% of 100? And once again, students would be doing side work. There'd be all this junk along the side of their paper. And I'm going, y'all, look, did you notice that this says 2.7% out of 100? Well, what does percent mean? It means out of 100. And so if it's out of 100 and percent means out of 100, there's no math to do here. 2.7% of 100 is just 2.7 because that's how many parts out of 100 already. Does that make sense to you guys?
Yeah.
Okay, cool. Now, we're going to use this kind of mathematical conceptualization in order to deal with some really common percents mentally so that we don't have to do ugly scratch work down the side of our paper with decimals. Okay, I want to avoid that at all costs. So let's use some common sense. Let's start with the most common percent you're going to stumble upon. And of course, that is what happens if you take one whole thing, 100%, and you break it into 2 equal pieces. If I break 100% into 2 equal pieces, well, 100 broken into 2 equal portions is 50. So I would have 50% and 50%. I would like to argue that 50% is the same as 1/2. Well, if 100% is one whole thing, and I break it in half and I get 50, well, then 50% must be half of one whole thing. 50% is half. Does that make sense to you guys?
Yes.
Okay, so now let's do some mental math with that. I don't think that I need to do any scratch work to find out 50% of 6, for example. What is 50% of 6? Well, what's half of 6?
3.
3, okay? And even if it gets pretty ugly and big, you guys can still use this skill. Let me not start quite so high. I'll do that next. Okay, so then 50% of 24 would be, again, half of 24. What's half of 24?
12.
12. What if I was that poor student who really struggles to have things in my brain? Could I have done that in my calculator some easy way?
Yes.
How? I can think of at least 3 ways. So anybody?
Divided by 2?
Yes, I could have taken 12 and divided by 2. One way to think about halving something is to divide it into 2 equal pieces. I would have gotten 6. But, you know, that's not the only way. Do you know that your TI actually does percents? So if you don't believe me, you could type 50% of 24 to your calculator. 50, there's a percent button, and then of means multiply, and I type in 50% of 12, and I do get 6. But like I said, we're going to do this mentally here. So 50% of 24 is 12. Very nice. So I like that Maricela said that halving something is the same as dividing by 2. So I'm going to use that to do this nastier one. Let's do 50% of 174. Now, you're probably not as good at halving 174 as you are 6 or 24, some smaller numbers. So if you need to divide by 2, that's fine. I'm going to divide by 2 using sight division because I like that better than long division. And yes, that's a cheap plug for my sight division video. You'll like sight division better than long division too. So let's see, 2 goes into 17, 8 times, remainder 1. 2 goes into 14, 7 times. And so 50% of 174 is 87. So now I want to just do one last tricky problem that throws students, not because they're not good at 50%, but because they're not good at paying attention to verbal directions. Anybody who's taken a GED test can tell you they have lots of weird, confusing directions. So we've got to pay attention. Yeah, Serenity's like, amen, sister. I got a hallelujah back there. Okay. So,
Yeah.
okay, so let's take a look at this. I have seen problems like this that come up and students just lose their mind. So this one, it says 20 is 50% of what number? And I see a lot of students who go, oh, 50% is the same as 1/2. I know what half of 20 is. Half of 20 is 10. And they write down that answer 10 and they are just wrong because they missed something in the wording there. Notice what I'm saying here. I'm not saying find 50% of 20, am I? I'm not saying find half of 20. Instead, I'm saying 20 is 50% of what number? 20 is half of what number? What number would I have to have in order to get 20? Let me draw a little picture of that. So I have something going on. And if I take 50% or half of that, I get 20. 20 is half of this. Well, what would the whole number be worth then?
40.
40, exactly. If one half's 20, the other half's 20, then 20 is 50% of what number? It's 50% of 40. Great, you guys, we're not fooled. So 100% is easy. 50% is easy. Let's look at some other percents that can be done mentally like this, okay? So we looked at when we broke this circle into 2 equal pieces, we could get 50 and 50. But it's not the only one that works really, really nicely, okay? So what I'd like to look at now are 25 and 75%. I think this one should be simple for all students because even if we're not used to 25% and 75%, we're really used to 25 cents and 75 cents in our pocket. You know, a lot of you guys have 25 cents in your pocket right now. We have a coin that's worth 25 cents. What coin do we have that's worth 25 cents?
Quarter.
A quarter. Say that one more time for me. What coin is it, Serenity?
Quarter.
A quarter. A quarter. And if we had a few of those coins, how many of those quarters would we need to have 75 cents?
3.
3 quarters. So what you're telling me is 25 cents is like a quarter. And similarly, 25% is the same as taking a quarter of something, breaking it into 4 equal pieces. If a whole thing is 100 and I break it into 4 equal pieces, quarters, that's why those fractions, fourths, are often called quarters. Each one of those quarters would be worth 25%. So what I'm trying to argue here is 25% is like 1 quarter. It's like breaking something into 4 equal pieces. Exactly. James wrote that as a fraction. Okay. 1/4 is one way to conceptualize this. Another way to conceptualize this, breaking it into 4 equal pieces. So dividing by 4 is another way to think of this. And so when I look at this, there we go. Let's do an example problem. Nobody should have to do side work with ugly decimals for this problem. Nobody who understands what percents mean. Because if I know what 25% means, that it means a quarter, it's really easy to take a quarter of 4. It's really easy to take 4 and break it into 4 equal pieces. If I took 4 and broke it into 4 equal pieces, how much would each piece be worth? 1. I'm just dividing by 4. So multiplying by 1/4, dividing by 4, same difference, super easy trick for this. Let's try it with a slightly bigger number. So if I wanted to take 25% of 20, again, I'm taking 20 and breaking it into 4 equal pieces. What would 25% of 20 be?
5.
5. Brilliant. Serenity, how'd you get that number?
I just did 20 divided by 4.
Exactly. 20 broken into 4 equal groups, or 20 divided by 4 is 5. Very nice. Okay, wonderful. So even if it got big and ugly, as long as it was 25%, you should be good to go. So let's see, let's find a challenging problem. Let's do 25% of 132. Again, at 25% of 132, you don't have to take 132 down the side of your paper and multiply by 0.25. You could just divide by 4, which would be a lot simpler. And because I'm lazy, I'm going to do it with sight division. So 4 goes into 13 3 times, remainder 1. And 4 goes into 12 3 times, and I'm done. So now I would argue that if you can do 25%, you can also do 75%. It's going to take us a little more work, but it's the same basic concept. Let me show you what I mean. Most of us, I'm going to go back to that diagram where I have 100% broken into 4 equal pieces. Each one of these is worth 25%, okay? So if I take more than one of them, like I take the first one, I'm at 25%. Now if I take 2 of them, 25 and 25 makes 50%. I take 3 of them, and yes, I end up with 75%, 25, 50, 75. 3 of those quarters is the same as 75%. So yes, 75% is the same as 3/4. Now let's think of what 3/4 means. 3/4 means break something into 4 equal pieces. and keep 3 of them. So we can totally do that. Like say, for example, I want to do 75% of 4. So, but let us think back to our 25%. When we took 4 and broke it into 4 equal pieces, we ended up getting 1 in each one of those. But I don't want 1/4. If I have 75%, I want 3/4. So I need 3 of these pieces. Well, 1, 2, 3. 3 of those pieces would be 3. Let's try to do 75% of 20. So 75% of 20. Again, I can do this mentally. I will do this mentally when I'm shopping or whatever. You know, I love a 75% off sale. If I am 75%, that's the same as 3/4. So I could quarter my 20. I'd end up with 5, 5, and 5. And then take 3 of those pieces. 5, 10, 15. 75% of 20 would be 15. Let's do 75% of 80. 75% of 80. So again, we said 75% is taking 3/4 of something. So we could break 80 into 4 equal pieces. If I break 80 into 4 equal pieces, how much is each piece worth?
20.
20. And then I want 3 of those quarters, 3 of those pieces. So if I took 3 of those pieces, how much would I end up with?
60.
Exactly. 20, 40, 60.
I'm very excited about this class.
Yeah. Oh, that's good. That's because you like to shop, isn't it, Maricela?
Yes, and I want to save money.
You know, I never used to start with an intro to percentages class. I always just used to start with the decimals. You know, I mean, you convert to decimals, you multiply, you divide. It always works. You don't have to memorize if this, then this. But my problem is I would teach these students and they would have no conception of it. I still have a student that I worked with many, many years ago who did pass her GED, but she's still confused by percents. She'll call me up in the grocery, or she called me up in the mattress store one time and said, this mattress is 5% off. And I keep doing the math and it's only 5 cents. And that's not a very good deal. So I love her and she's one of my closest friends. And I hope she's not, hurt that I'm sharing this example, but she just had these steps memorized. She forgot a step, but because without that conception, it didn't make any sense to her. So yeah, 5 cents off $1,000 mattress doesn't sound so great. Now she was doing her problem wrong, but she couldn't figure out why, because she lacked that understanding. Have you been there? Have you been there? Like, I remember this was easy in class. It's not working.
Several times.
So I got my trick for 25%. I'll take 1 of those quarters. I have my trick for 75%. I'll take 3 of the quarters. I'm going to show you a cool trick. Does anybody struggle to know how much to tip when they go out to a restaurant?
Sometimes, not all the time.
Yeah, some people really struggle with that. Nowadays, they're like printing it on the receipts because people are so bad at math. But this mental trick I have will help with that. Anyway, it will if you're like me and you tip 20%. And let us talk now about another little neat mental trick. Let's talk about what we can do for 10% and its multiples. So once again, in order to understand 10%, I need to understand 10%'s roll out of 100. So we saw that 50% was half because 50 is half of 100. And we saw that 25% was a quarter because 25 is a quarter of 100, and so on and so forth. But 10% is what portion of 100? So if I have 100 and I'm looking at just 10%, how many equal pieces have I broken 100 into?
10.
Exactly. 10 equal pieces. There are 10 tens in 100. And so I would like to say that taking 10% of something is like breaking something into 10 equal pieces this time. So it is like dividing by 10. 10% is 1 of those pieces out of 10, and so it is like dividing by 10. Well, there's something really cool when you divide by 10. So I'm just going to ask you to remember. Some of you have been with me before when we've noticed this cool thing. Some of you haven't. So if this is the first time you've heard it, that's fine. But it's really, 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 really easy to multiply and divide by tens. Tens are so super simple because we have this 10-digit number system. All that ever ends up happening when you multiply and divide by tens is you have place value changes. None of your important numbers change, just their place value changes. Okay, so let's just think, for example, like if I were to take 75, actually, let's start with 70. Let's start a little easier. If I was to take 70 and divide by 10, what would I get?
7.
It's 7. And Serenity didn't find that hard at all. She didn't have to use her fingers. She didn't have to write anything down. How'd you know it was just 7?
Because of the place value.
Yeah, basically I just lost a place value when I divided by 10. I just lost one of my places. My decimal place moved up and I'm at 7.0 or just 7, you know? And so even if it's not a nice number that doesn't seem to divide nicely by 10, you can still use this trick. So a lot of students are like, oh no, 75 divided by 10, I can't do that. Well, yeah, you can. Just start. Right now, this is like 75 whole dollars. So it's like the decimals at the back hand side. And if I divide it by 10, I would just lose one decimal of place value and I'd get 7.5. So what I'm saying here is 10% is the same as dividing by 10. Can I say taking 10% is the same as dividing? I want to be clear.
Yeah.
So taking 10% is the same as dividing by 10. And so we can take 10% of something by just moving over a decimal place. Lose one decimal place of value. Okay, so now super duper easy. Let's take 10% of 1200. And James said that taking 10% is like in tithing. Yes, for those of you who tithe, that's a common percent to do, and it's really easy to do because all you have to do is lose a decimal place of value, and then you know how much. So if there's 1200 here, and I want to take 12% of it, sorry to put an equal sign, I meant to put the word of, I am just going to take the decimal from where it is at the back, move it one over, and that is the same as 120. Now, some of you guys are like, what kind of ninja magic are you doing, Kate? What happened to the decimal you were just talking about? Yes, that's the same as 120.0, guys, but I don't brag about 0 decimals, and so I just drop it. That's 120. Then it's super duper easy. We could take 10% of anything. I don't even care how ugly it is. Let's do 10% of 717. So this is 717 whole things right now. So that decimal's at the backhand side. So I'm going to lose one decimal place and I get 71.7. What if it already has a decimal? Some students get thrown by that. 10% of 345. Well, again, I'm just going to lose a decimal place of value. I want my number to be worth less than it was before. And so my decimal is going to go off to that left. Boom. And I would get 0.345. There is nothing wrong with that number. It doesn't matter if you have a decimal or you don't have a decimal. It's still the same basic procedure. Okay, so now I'll use this to show you my tip trick. Okay. When I'm in a restaurant, I do not struggle to come up with the tip at all, and I love to eat out, y'all. I just always tip 20% because I worked in the restaurant industry. How many of you guys have worked in restaurants? Have any of you worked in restaurants? Serenity, does it suck to work in restaurants? Do people treat you like crap?
Yes, we do.
For wait staff. Okay.
Yes.
So anyway, I always tip 20% because I worked enough years in restaurants trying to support a family. So if I wanted to do like 20%, let's say, of a, now, you know, restaurants are getting really expensive.
Mm-hmm.
Let's say it was a $43.40 bill. So I want to tip 20% of it. The first thing I do is start with that 10% trick. I would start with 10%. I know by just moving over the decimal, I get 10%. So 434 would be tipping 10%. But I don't want to just give them 10%. That's not very generous. I want to give them 2 of those pieces. I want to give them 2 10% pieces. They'll have a total of 20%. I'm counting by tens. 10, 22, 10% pieces is 20%. And so I'm just going to double that. I'm going to add on another 434, and really easy to compute the tax. And I didn't have to multiply and divide with decimals, which sucks. Shall we try one more? Dear Lord, you know I have a family of 8, so the bill was probably more like $85. When you drop $85 on crappy food, you feel bad for yourself. I'm trying not to feel too sorry for myself, y'all. Let's do 20% of 85.75. Now, first of all, I started by doing what? Anybody remember what was my little trick?
You move the decimal point.
Yeah, I'm going to move the decimal to just get 10%. So I'll move that guy over. And that is 8.575. Now, something weird happened with my 8.575. It doesn't look like money to me. Now, students lose their mind. Yeah, don't worry about it. We'll worry about it at the end, okay? I'll round at the end. But that was one 10%. Here's another 10%. And if I add up my 10 and my 10%, it should give me 20%. So let's do that. So 5 and 5 is 10, 14, 15, 10, 11, and I should tip my waitstaff 16.15. And now there's no rounding to think of because that's a 0 anyway. So you can use this trick for any multiple of 10. Sure, 40. So let's go through our multiples of 10 real quick. My multiples of 10 are anything on the 10 times table. So I'm thinking 10%, 20%, 30%, 40%, 50%, 60%, so on and so forth. Now, just because James said 40%, let's try one with 40%. For example, if someone asked me 40% of 324. Now, Don't get me wrong. I can do this very standard convert to a decimal, multiply, the thing I'm going to teach you next class. If you've learned that before with another teacher, there's nothing wrong with that. But this is a mental math trick, okay? So if I'm going to do 40% of 324, I could lose a decimal place of value. So this is a whole number. So that decimal's at the back. I'm going to move over 32.4. And that represents 10%. But I don't want 10%. I want 40%. I want 4 tens, 10, 20, 30, 40, 4 tens. And so I would have to take this now and I could add it up 4 times, but I'm too lazy. I'll just multiply by 4. I'll take 4 of those pieces. So 16, 8, 9, 12, and I get 129.6. Now that being said, this isn't the only way to do this problem. I just like this way for mental math. If I were doing this on scratch paper, I probably might use another method. But when I'm in the store, this helps me. And a lot of times when I'm in the store, I'm going to approximate. I'm going to round decimals. I probably wouldn't call it 32.4. I'd be like, it's about $32. 4 times, that's about 120. You know, we're doing this for mental math strategies. Okay, so like, oh, girls, these ladies know that we see 70% off and we get so flippin' excited. It's getting me just excited just thinking about it. Okay, so let's try 70% of 200. This would be really easy to do with mental math with these nice round numbers. So again, I would start by finding 10% of 200. What's 10% of 200?
20.
Yeah, 10% of 200, I just lose a decimal place of value, I get 20. But I don't want just 20, or just 10%, I want 70%. So of course, 70, if you think about counting by tens, 10, 20, 30, 40, 50, 60, 70, I'm up to 7 tens. So I need 7 of those $20. Does that make sense? And it's easy to count by 20s too. So 20, 40, 60, 80, 100, 120, 140. I don't have to do any paperwork, and that's what I was looking for. I was not even trying to reach into my purse and do some scratch work with decimals. I'm looking for mental math when things are on sale, okay? I'm shopping, not doing homework. This is when it's particularly useful. So maybe we'll do one more and you guys can walk me through it. Let's do, I don't know, 30% of 80. Help me do 30% of 80 mentally, guys, using this little trick.
So when I just move like the decimal point to the left,
Yep. I'm going to move it over to the left to get my 10%. And what would 10% be then?
8.0.
Or just 8. Exactly.
8,
0
yeah.
decimals do not matter. So it's 8. It's 8. So, you know, 10% would be $8. So then what would 30% be? Well, just count by 8 3 times. So 8.
24.
24. And James, you got 24 by counting by 8. 8, 16, 24?
Mm-hmm.
Yeah, 3 8s. Exactly. If each 10% is worth $8 and I have 3 10%, then I have 3 $8 chunks. I hope that makes sense. Does that make sense?
Yes.
Sweet. In this case, it made dollars. Math teacher jokes. Sorry, only I laugh at my jokes. That's okay. Serenity gives me a little pity laugh. Let's do 60% of 500. Help me walk through this trick. So let's start with 10%. What would 10% be?
50.
10% would be 50, but I don't have 10%. I have 60%. I have 6 of those same pieces. So if I have 6 50s, that's how much?
300.
Yeah, 300. 50, 100, 150, 200, 250, 300. Absolutely. $300. Well, that's nice. And guys, even as I'm doing this problem, I can think of 2 other mental tricks I could have used. If you use some other mental reasoning trick, as long as you're using it successfully, there's lots of different ways to do lots of different mental math. This is just one little trick I got in up my sleeves, okay? That being said, if you want to share your amazing mental math percentage trick that you have, I'm sure people would love to hear it. Can we talk about when things are more than 100%? I don't know what it is about 3rd grade. Like, there was just something that happened in 3rd grade that made us think that fractions couldn't be improper and percents couldn't be over 100. Like, it's just not possible. And I'm like, y'all, number systems don't stop at 1. Can I just say that again? Our number system doesn't stop at 1. Remember that 100% just means one whole thing. Y'all, we don't run out of numbers past 1. We have numbers past 1. We can handle this. We can handle things that are above 100%. So if you have anything above 100%, it means you have more than one whole thing. Let's start with 200%, for example. Well, if I say you for example, you could be a salesperson and you could do 200% of your sales budget. Or your sales goal. What does that mean? You did more than your goal. In fact, if you did 200%, well, let's think about it. 100% is one whole thing. Another 100% would be another whole thing. Guess what? If you did 200%, you did two whole things. You did twice as much. Okay, so we can stop losing our minds and giving me really weird answers with decimals all over the place. Scratch work to here, erase marks. So hard you rip the paper when you have to take 200% of something. James, I see your hand is raised. Do you have a question?
Yes.
What's your question, sir?
I think that 125% is one whole thing plus 1/4.
James, you're flipping brilliant. I haven't even gotten that far yet, but you're absolutely right. That's what 125% means. It means you have one whole thing plus a quarter of a whole thing. It's like saying 1 1/4. Very, very nice. Okay, so let's come back to 200% of 5 though. If I'm saying 200%, I'm saying two whole things. So I want 2 whole 5s. Well, what happens if I get 2 5s? I have twice as much as 5. I end up with 10. So guys, 200% is like saying, taking 200% of something is just like saying times it by 2. So then what would 200% of 40 be? Remember, 200% means twice as much. So what's twice as much as 40? Or what's twice 40?
80.
Exactly. Serenity, I didn't see you do any scratch work. How'd you come up with that number?
I just did the 2 times 40.
You just did 2 times 40, doubled 40. Wonderful, wonderful. And so that same thing is true for no matter how many 100% you have. Like if you had 500% of something, well, let's think about what 500% means. If each 100% is one whole thing, how many 100% do I have in 500%?
You have 5 100%.
I have 5. Exactly right. So it's not one whole thing, it's 5 whole things. I'm asking for 5 3s. I'm asking for 5 times 3, 5 3s. And of course I would get 15. Okay, let's keep applying this logic. And what would 400% of 7 be? How many times as much is 400%?
4.
Exactly. 400% is like 4 times as much. So 4 times 7 is what?
28.
28. Glorious. Let's do, I don't know, 300% of 11.
30.
33. James, I didn't see you do any scratch work. How'd you come up with that?
3 times 11.
Exactly. 300% is 3 whole things. So 3 11s would give me 33. Exactly right. Exactly right. And this is actually the last mental math trick I want to teach you. But I have to tell you the truth, if you watch this video and you just close out the video and don't go practice this, you won't remember any of them because we just learned a bunch of different tricks. If it's 50%, do this. If it's 25%, do that. If it's 75%, do that. If it's 10%, do that. If it's a multiple of 10, do this. If it's a multiple of 100, do that. That's a lot of different tricks to remember, and you won't remember it unless you practice it a few times yourself. Standard research shows that it takes about 30 times of you practicing something before you're going to have a test taking knowledge of it. And that's for an average learner. So if you're the kind of learner who's always struggled with math, you're going to want to do more than 30 attempts in order to really cement it for the test. I thank everybody for joining me today. So super glad to not be talking to myself. And join me for next class when we do learn, well, what are we going to do when we don't have those mental tricks? What if it is like James brought up 15% or something even weirder like 32.952%? Okay, that I don't have a mental trick for. I would have to do some ugly computations. We'll be practicing with that. We'll look at it arithmetically and algebraically because I prefer it algebraically myself, and we'll use our TI calculators to do the nasty work just like you would have on the GED. So until next time, see you later.